Hi guys and welcome back. My name is Miss Danielson and today we're looking at order of operations. You may have seen a previous BEDMAS lesson of mine, but this one is going to focus mainly on calculations which involve exponents. Feel free to check out the previous lesson. I'm linking it down in the description box below. Otherwise, let's just get started. BEDMAS. What does it mean? What do the letters stand for? First we have B, and B stands for brackets. Not all calculations involve brackets, but if you do see brackets in a calculation, you need to remember to work out the calculation inside the brackets first. Next comes E, and E stands for exponents in BEDMAS. It stands for indices in BIDMAS, and power of or order of in BODMAS. An exponent, index, or power is simply the little number that is above a big base number, and that tells us how many times we're going to multiply the base by itself. Exponents, indices, and powers are all the same thing, which is why some people say BIDMAS, some people say BEDMAS, and some people say BODMAS. It doesn't matter as long as you follow the correct order. Next, we've got two letters which are both in yellow. That's because these two letters are two operations which happen at the same time. So next is division or multiplication. And I don't mean that they're going to happen simultaneously, but I mean they'll happen in the order that they appear in. So sometimes you'll say BEDMAS, sometimes you'll say BEMDAS, depending on the order of the calculation. Next, we've got two more letters also in the same color, A and S. They stand for addition and subtraction. And once again, if you see several calculations in the same question, and there are some additions and some subtractions, you'll work them out in the order that you see them in the question. Again, we'll show some examples to make sure that that's clear. First, let's clarify brackets. Brackets are used in a calculation to separate some of the terms from some of the other terms. This helps us to clarify which values are being operated on and which ones are not. So let me show you an example. Here we can see 4 is being multiplied by, and in brackets I've got 2 plus 3. These brackets help to show me that I am going to multiply the 4 by the 2, and I'm going to multiply the 4 by the 3, but I'm not going to multiply the 4 by the minus 6. In order to do this correctly, I should always try to work out the calculation inside the bracket first. Sometimes brackets are used to show that this is a multiplication without needing a multiplication sign. I could have written it like this. When you've got a number directly in front of a bracket, that number is telling you how many of these brackets I want, so how much times this bracket. Again, we still need to work out what's inside the bracket before we do that multiplication. So I want 4 of this answer of 2 plus 3. Well, 2 plus 3, that's 5. So I want 4 of these 5s. That means 4 times 5. And of course, we need to remember that we're going to subtract 6 from that answer. So 4 times 5 minus 6. The next calculation that we're going to do is the multiplication, because in BEDMAS, multiplication definitely comes before subtraction. So 4 times 5 is 20. Don't forget, we still need to subtract the 6. 20 minus 6 is 14. Notice I've shown every step of my working, and although I didn't actually subtract the 6 until the last step, I always remember to write it down so I don't forget that that's something I still need to do. Let's try another example with brackets to make sure this is really clear. Here I've got two sets of brackets in this question, so I'll need to work out what's inside each of those brackets before I do the division I see between them. The result of the first bracket will then be divided by the result of the second bracket. So 5 plus 4, that's 9, and 6 minus 3, that's 3. So I'll put them in the same order as I've seen them above. That's 9 divided by 3. Now I can do that division. 9 divided by 3 is 3. We can show this in a different way as well. When you use fractions, you can clearly see that the numerator is separated from the denominator. So we don't need to use brackets to show that, but it works in the same way as brackets. First, we need to work out the value of the numerator, so 5 plus 4, and the value of the denominator, so 6 minus 3. And then, remember, a fraction is just a division of the top divided by the bottom. So that's going to be 9 over 3, which is 9 divided by 3, which is 3. Next, let's have a look at exponents, or powers, or indices. Again, they tell us how many times we need to repeatedly multiply the base number by itself. As we're going to be looking at a lot of exponents questions today, I want to make sure that we don't get confused about simplifying expressions and using index laws, as I know we've been studying that this year. So don't group exponent terms which are being added or subtracted. For example, 2 to the power of 2 plus 3 to the power of 2. Even though they have the same power, we can't count these as like terms. We are not going to add these two terms together, certainly not before we sort out the exponents. 2 squared means two 2's being multiplied together, and 3 squared means two 3's being multiplied together, not 2 times 3. Next, let's actually do that multiplication before the addition. So 2 times 2 is 4, and 3 times 3 is 9. So we're going to do 4 plus 9. Our final operation is an addition. 4 plus 9 is 13. Notice how this is different from grouping these bases. If I were to add these bases before I raise them to a power of 2, I would need to put that in brackets. So 2 plus 3 in brackets squared would be 5 squared. And then raising 5 to the power of 2, 5 times 5, that is 25. These answers are not the same, showing that these are not like terms that we can group together in this way. Let's try another example. Now, even though 5 to the power of 3 and 5 to the power of 2 are both index terms with the same base, there is no power law for when we're adding two index terms with the same base. That's only for multiplication, division, or power of a power. So let's try not to get that confused. So working this out correctly here, first we'll sort out the indices. So 5 to the power of 3 is 3 5's multiplied together. That's 5 times 5 times 5, not 5 times 3. And 5 squared is 5 times 5. Right, so 5 times 5 will be 25, multiplied by another 5, that's 125. So 125 plus 25, that makes 150. Now let's just see what that would have been had I erroneously tried to use power laws. Now, keep in mind, we only add together our indices when we've got two index terms with the same base, which are being multiplied together, not added together. You'll see that this is not the same as the previous example. 5 to the power of 3 plus 2 would be 5 to the power of 5. That would be 5 5's being multiplied together. Now I hope that you can already see how that would be different from what we'd previously done. Here I have 3 5's multiplied together, added to another 2 5's multiplied together. 5 5's multiplied together would be 5 times 5 is 25, times another 5 is 125, times another 5 is 625, times another 5 is 3,125. There is a huge difference between these two questions. So as we can see, we cannot group these index terms. Even if they have the same base, if these index terms are being added together, there is no index law that tells us what to do with those indices. So just follow order of operations, please. Next, let's have a look at multiplication and division. Why do they happen at the same time? It's because they're essentially the same operation. Let me show you an example. 4 divided by 2 is the same thing as 4 times a half. So when we see a multiplication and a division in a single calculation, we will perform them in the order that we see them in. Let me show you an example. Here I've got 5 plus 3 multiplied by 8, then divided by 6. So even though the order of operations for BEDMAS says D before M, we could just as easily say BEMDAS, although it sounds a bit funny, and do the multiplication first, because in this case the multiplication appears first in the calculation. We are not going to let addition jump in front of the multiplication and division, however. So working this out, I'll just write 5 and add to that the answer of 3 times 8. And then I remember I need to divide by 6. So that's 5 plus 24 divided by 6. Next, I'm not going to add yet. The next thing I want to do is divide. So I'm going to do 5 plus and the answer of 24 divided by 6. So 5 plus 4. Now there's only one operation left, an addition. So I'm going to go ahead and perform that addition. 5 plus 4 is 9. To finish off our acronym, we've got A and S, addition and subtraction. And they're in the same color because they happen at the same time, just like division and multiplication. They're essentially the same operation. Think about 7 minus 3, for example. It's the same thing as 7 plus negative 3. So the order that we perform our additions or subtractions in follows the same order that we see them in the calculation. So let's see another example. 7 minus 4 plus 3. Here I see the subtraction before the addition. So thinking about BEDMAS, I could actually consider this as BEMS. Oh, it's difficult to say. So we say BEDMAS, although in this case the subtraction is going to come first. So 7 minus 4, that's 3. So we're going to do 3 plus the 3, which is 6. Note that this is different from 7 minus, and in brackets I've got 4 plus 3. In this case, even though I see the subtraction before the addition in this calculation, we can't ignore the brackets. We know brackets always comes first. So here we would do 7 minus, and 4 plus 3 is 7. So 7 minus 7, and that is 0. You see how order of operations is important? And we always follow BEDMAS order of operations, whether you're reminded to do so or not. Now that we've been through all of our order of operations rules, let's go through a few examples. Note that all of these examples will involve exponents. In this first example, there are no brackets here, but there are exponents. Let's work those exponents out first. So 2 squared is 4, plus 3 squared, that's 9, and we're going to times that by 4. But in which order? Will we add or will we multiply next? There are no brackets. There are no longer any exponents. The next operation should be either division or multiplication in the order they appear. And I just see one multiplication here. So next I'm going to multiply. But let's start by writing the terms out in the order that they're given in. So although I'm not doing anything with the 4 right now, I'm going to write 4 plus, and I'll work out the answer of the multiplication. 9 times 4 is 36. Next, there's only one operation left to do, and that's an addition. 4 plus 36 is 40. Let's try another example, but this time with a fraction. Now, don't be afraid of fractions. Fractions are just a numerator, that's the top expression, being divided by the denominator, that's the bottom. So we're going to treat this like it's a division, but this division is clearly separated by this line, in the same way that we separate some terms in a calculation using brackets. So the line in a fraction works the same way as brackets do. So we're going to start with the B, the line, the brackets, and we're going to work out what's at the top and then work out what's at the bottom. So on the top we've got 5 plus 3 squared. What are we going to do first, adding or the squaring? We're going to do the exponent first. 3 to the power of 2 is 9. And on the bottom, we see that there's an exponent there as well. Let's work that out. 2 squared is 4. So 5 plus 9 over 4. Remember that line there means a division. First, we need to work out the numerator as it's separated by that line, just like it's in brackets. So we're going to do the addition. 5 plus 9 is 14, which is being divided by the denominator 4. There's only one operation left, division, and 14 divided by 4 is 3.5. One last example, so let's make it a good one. I've got 2 sets of brackets here, and this second bracket has got a number in front of it. Not only is that a number in front, it's a negative number in front. Remember, when there is some term directly touching a bracket, that is being multiplied by the bracket. But let's follow order of operations working through in the correct order, and we'll worry about that multiplication when we come to it. The first thing we should deal with are these brackets. But inside these brackets, I see multiplications, I see powers, I see additions, I see another power. We should be dealing with the exponents first. So in this first bracket, we're going to do 3 times and the answer of 2 to the power of 4, which is 16. For the second bracket, first we'll write minus 2 in front of it, and then we'll put 3 plus the answer of 2 cubed, which is 8, and that bracket is being squared. So I'm still writing all of my terms in the same order as above. The only thing that's changing is that I'm performing my exponent operations. Next, we're still looking at these brackets, and I still see that there's some calculations to be done. In this first bracket, I'll need to do this multiplication. So 3 times 16, that's 48. And in this next bracket, I'll need to work that out. 3 plus 8, that's 11. But again, I'm writing all of these terms in the same order as above. So the answer to this bracket, minus 2 times the answer of this bracket, squared. What should we do next? We do have brackets here, but what's inside that bracket has already been worked out. So going from brackets onto exponents, I do still see an exponent in this question. This 11 is being squared. We'll start by writing all of the other terms in the same order, but then we're going to work out that exponent. So 48 minus 2 times, what's 11 squared? 121. Okay, so there's no more exponents left there, and although we see these brackets again, there's nothing inside these brackets to be worked out. So there's no brackets, there's no exponents. Is there any divisions? No, but there is a multiplication. This 2, which is sitting outside this bracket, is being multiplied by what's inside the bracket. And be careful with the sign here. There is a minus. So we're going to start with the 48, and we're going to minus. 2 times 121 is 242. We've got one operation left, and that's subtraction. 48 minus 242. Obviously, that'll give us a negative answer because we're taking a big number from a small number. That's negative 194. Before we get into the practice exercise, let's just do a quick recap. BEDMAS stands for brackets, and that always comes first. Then we have exponents or indices or powers. Then we've got division and multiplication, and the order that we do these in depends on the order that we see them in. And then we have addition and subtraction. Just like multiplication and division, we do these in the order that we see them in. Before you do the exercise, make sure you know what BEDMAS stands for. You know that fractions separate terms in a calculation in the same way that brackets do. So solve the top, solve the bottom, and then do the division. Also, you need to understand that performing calculations in the wrong order will give you the wrong answer. You need to use correct BEDMAS order of operations and perform these calculations mentally. No calculators here, please. And show all stages of your working, step by step. That way, if you made a mistake, we can figure out where you went wrong in your order. On to some practice now. Take your time to copy these questions out carefully. Make sure that you open the bracket and close the bracket in the right places. So hit pause now, show all your working in correct BEDMAS order of operations, as always, and hit play when you're ready to take up your answer. I hope you had a chance to hit pause, because here come the answers. For question 1, 2, and 3, notice that these calculations all look very similar. 2 to the power of 4 divided by 2 squared plus 6 squared. The only difference is the brackets that we see in question 2 and 3. Following correct order of operations for question 1, first the exponents, then the division, then the addition. For question 2, first the brackets, and inside those brackets, we'll work out those exponents. Then inside the brackets, we'll work out that addition. Now we've got an exponent and a division. Let's start with our exponent and then divide. Completely different answer from question 1. For question 3, I see some brackets, and within those brackets, I see some exponents. I still have brackets, and within those brackets, I've got a division. Now I've got an addition and an exponent. We'll start with the exponent. And finally, we've just got an addition. Notice that question 3 gives the same answer as question 1. I wonder if you could explain to me why down in the comment section. Why didn't those brackets affect the answer? On to questions 4, 5, and 6. Again, you should have noticed that these are all very similar. However, there's some brackets involved. Question 6 is a fraction, but as we know, fractions are divisions. Are these answers all the same? Starting with question 4, let's work through those brackets. Inside those brackets, I see exponents. I still have brackets, and inside those brackets, I see an addition in the first one and a multiplication in the second one. Next, I've got a number in front of a bracket. That means multiplication, and I'll go multiplying before the division that comes after it. And then I'll finally do my last operation, my division. For question 5, I see we've got brackets. We'll work out the exponent inside the bracket first, then the addition inside the bracket. Then going in order, I see multiplications and divisions, starting with the first multiplication. 5 in front of a bracket is being multiplied by the bracket, so 5 times 5. Then I see a division, the 25 is being divided by the 10. Let's go in order here. Then we're going to multiply that answer by 4. Completely different answer from the previous question. Question 6, however, is it the same as question 4 or the same as question 5? Start by remembering that a fraction separates the top from the bottom, as if we're using brackets. Let's first work out what we've got on the top, and on the top there are brackets, and inside that bracket there is an exponent. So we'll work out that exponent first. On the bottom I see a multiplication and an exponent, so we'll work out that exponent as well. Next, let's work out what's inside the bracket in the numerator on the top of the fraction. Then we can do our multiplications. Both the top has got a multiplication and the bottom's got a multiplication. Finally, 25 over 40 means 25 divided by 40. And we got the same answer as question 4. Again, who can tell me down in the comment section why question 4 and question 6 give the same answers? Finally, questions 7, 8, and 9 are also very similar. Which of these answers are the same? Starting with question 7, working out the top and the bottom separately, and finally dividing our answers. On the top, we've got some exponents, and on the bottom, we've got an exponent as well. On the top, let's do that addition before we divide by the denominator, and that gives us 1. That was nice and tidy. What about question 8? Here we've got brackets, so let's work out what's inside the brackets first, starting with these exponents. Then we'll work out what's inside those brackets by doing that addition. Finally, we've got a division and we've got a power here. So let's work out that power. And we'll do the division. 25 divided by 25, same as 25 over 25. Both of these answers are 1. Can anybody tell me why they're the same? Is 9 going to be the same? Let's work it through. There's no brackets this time, but I see loads of exponents. So let's work through these exponents. Next, I see there's an addition and a division, but division comes before addition in BEDMAS. So we'll do the division first, 16 divided by 25. And then we'll do our addition. No, question 9 is not the same as question 7 or question 8. So those brackets do definitely make a difference. Let me know if you can tell me why. Now, I hope you found this lesson helpful and interesting. Please let me know down in the comment section if there are any doubts. Otherwise, just keep practicing, and I'll see you soon.